Okay, so today we're going to talk about relative frequency tables. So we already talked about two-way frequency tables yesterday, right? That's where we have two different types of data being compared so that we can more easily digest that information. Like this one is the types of ice cream with the types of toppings, right? What people prefer. People that prefer vanilla with nothing on it is completely mind-boggling to me because I don't understand that. Vanilla is only good if it has like chocolate or something else in it, right? Am I right? I feel like I'm right. Anyway, so that's what a two-way frequency table is, right? You got one set of data, comparing it with another, and then you can like add through the columns or the rows to figure out different things, right? This is how many people like the vanilla ice cream, 30, how many people like chocolate, 20, which is also weird to me. Who likes vanilla more than chocolate? But whatever. I did not make the data. I'm just looking at it. Okay, anyway, that is a two-way frequency table. A relative frequency table is very similar, but instead of looking at the raw data, so the actual numbers, you break it down by percentage, okay? That'll give you an overall picture of what it looks like if you were breaking it down by percentage. Usually when you get into like some big numbers, it's much easier to be able to understand what it is than if you were looking at just the raw data. Like if you're looking at thousands of things, like 250 like doesn't really mean much, right? Like it wouldn't make or it wouldn't have a lot of meaning. But if you're like 250, that's 1/4, that's 25%. Like, oh, okay, 25% of people, like vanilla, like that kind of thing. So basically it's the same idea, just broken down by percentage. That's what makes it a relative frequency table. So to make it a relative frequency table, you divide each number in the row by the total number, basically, okay? So by the total in that row, that's not right. So you would divide it by the total number of participants, basically. I'm going to ignore what this says because it's not right. You want the total number of participants, okay? This down here should be like 100%. They don't have this row on here. Oh, that's why. That's for rows if you wanted to include columns. So we're going to ignore number 2. We're just going to focus on number 3. Actually, let's just do number 4. Well, we'll do number 3. So there's two different ways you can present it, okay? So to present it, well, let's do number 4. Sorry. This is what a two-way frequency or relative frequency table should look like. So we're going to divide everything by 50 with this raw data. Sorry, I should have looked at this a little bit more closer. So, for example, we would take 9 divided by 50 to get the percentage there. Okay, so 9, what is on my calculator? 9 divided by 50 is 0.18. So sometimes the relative frequency tables will leave it as decimals or they'll convert it to percentages. So you could see it written as 0.18 or you might see that as 18%. Okay? Either answer is correct. Just really depends on what all the data is. You can't have decimals in one and percentages in the other. If you start with percentages, everything's going to be percentages. Okay? And to convert that to a percent, you would just move that decimal 2 spots to the right. Times it by 100, basically, right? 0.18 times 100 is 1/8. Okay? Or 18%. So that's all we would do to convert these decimals to a percentage. Just move the decimal 2 spots. Okay, so I'm going to go through and I'm going to divide all these numbers by 50. I'm going to leave it kind of up there so you guys can see. So 8 divided by 50 is 0.16. So I would have 16% for the vanilla and M&M. 13 divided by 50 is 0.26. So 26% of the people surveyed here like vanilla with nothing on it. Nah, that's not right. Can't be right. 30 divided by 50 is 60%. So 60% of people like vanilla. Okay. And then the other data here, so chocolate, 7 divided by 50, like 14% like chocolate with sprinkles. 9 divided by 50 is 18%, I already know that. 18% like chocolate and M&Ms, which is a weird combination. You don't put chocolate and chocolate together. Weird people. 4 divided by 50, only 8% like chocolate with nothing on it. These people are weird. And then 20 divided by 50 is 40%. Okay. Now, I could add these down, but really the appropriate way to do a relative frequency is to take everything and divide it by 50. If you have that data, you should be dividing everything by that. Because sometimes you get like those weird decimals, they got a round, like 0.3 repeating or something like that. So that it's not accurate if you add across generally with the relative frequency table. It can be if everything's nice, like this is going to be, but not always. 16 divided by 50 is 32%. 32% like sprinkles. 17 divided by 50 is 34%. 34% like M&Ms. And 17%, so 34% like nothing on it. And that would bring us to 100%. 50 divided by 50 is 1, which would be 100%. Okay, that is a relative frequency table. That's just taking this data up here and turning it into a percentage. That can make things look a little bit more clear, right? I can see, like, instead of 30 out of 50, I can see 60% out of those people like vanilla, because there's 60% of those people are weirdos. So I'm not, you guys might think I'm like opposed to vanilla, but I'm not. I like vanilla. It's fine. It's fine. It's just kind of boring. Okay, let's look at some other examples here. So these are all just kind of converting to relative frequency tables, which is fine, but you're just dividing by the total. Like, again, if you look at like this one in particular, this kind of stuff like is kind of just like 104. English in 6th grade is their home language, and 56 have other. Like, that doesn't mean much to me, right? But when I break this down by percentages, it would start meaning a little bit more, right? I can get a greater picture. So, like, for example, table shows grade levels in the primary home language. I can see at this middle school, if I do 221 divided by 540, that 41, or about 41%, it'd be 40.9% of those students, in total, they don't even have a 40.9% of those students have a different language other than English as their primary home language at that school. So almost half the students have a different home language. That's a little bit more clear than 221 out of 540, right? Means a little bit more. Okay. That is basically what you're going to be doing. It's going to ask you some questions, like on this one, I'll ask you, like, here's a two-way frequency table, here's a relative two-way frequency table. Which one would you rather have? Like, which one makes more sense to you? It's talking about car ownership, right? This is by row, so it's saying, of the male students, how many own a car? 28% say yes, 72% say no. So that would be, a little bit more clear than 49 out of 175, right? So which one would you rather look at, okay, to get your answer and justify it? explain why you would rather see one over the other. Okay? Then, on some of these, like it's just going to ask you to fill in a two-way frequency table. And on others, it's going to ask you to make a relative frequency table. Okay? So on these, I guess I'll show you since it doesn't actually have it listed, but some of these you would do it by row. So like let's, for example, look at number 3 on here. This one's going to have you set it up by row for a total. So this is going to be 100%. Okay, all of these are going to be 100% because that is how it is set up. Okay, and then I would say like 3 of the students with blue eyes have blonde hair. So 3 divided by 6 is 50%. I'm just going to do this one by decimals, so 0.5. Okay, 1 divided by 6 is 0.16, repeating. Okay, and then 2 divided by 6 is 0.3, repeating. And that would be 1. So sorry, not out of 100%, but 1. Okay, so if I add those up, that should equal 1, right? 0.3, and then that's a repeating, plus 0.6 repeating would be about 2, or 4, I mean, 5, sorry. Because that's 0.33, right? And that's 0.16, so that'll be 4, and then like the 3 and the 5, 6 would average to be about another 1 together. Okay, the repeatings, they're close. That's why the decimals ones aren't super accurate. Okay, and then brown, there were 15, so 2 divided by 15 is 0.13 repeating. 7 divided by 15 is 0.46 repeating. And 6 divided by 15 is 0.4. Okay, it should all add up to be about 1. And again, last one is green eyes. There's only 4. So 1 divided by 4 would be 0.25, 0.25, and 0.5. And that's the relative frequency table. And again, that's all you're basically doing today. If you have any questions or concerns, let me know. I'm here to help. I want to help. And I'll see you guys out there.